Hi, hello everybody. We are going to wait 2 minutes in order to allow people to join us, and then we are going to kick off. Okay, let's kick off. My name is Ariel Bocio. I am Vice President of the Argentina-Texas Chamber of Commerce, and it's a pleasure to be here to share with you this new webinar, Smart Contract Trends in the Energy Sectors, where we are going to talk about blockchain and a smart contract general approach, how this 4.0 technology is impacting the energy sectors and business trends. But before going there, I would like to talk a bit about our next event in Argentina, November 10th, that is the Argentina-Texas Summit, Technology and Innovation. And the title of this summit is Consolidating Argentina as the Silicon Hills of Latin America. This is a very important event. We expect to have there about 200 key people in the industry from Argentina and Texas, representing the governments, the private sectors, and different organizations. In that summit, the main topics are going to be about digital transformation, how the bilateral relationship can help companies and the two regions to create opportunities. And we are going to have an amazing speaker lineup that we are going to have the Mark Stanley, that is the ambassador of US Embassy in Argentina, people from the Argentina Secretary of Knowledge Economy, the Secretary of Innovation and Digital of the City of Buenos Aires, the Global Chief of Technology Officer at Global Argentina, and also Ronald Peña, that is the Senior Vice President of Global Tech and Innovation at Austin Chamber of Commerce. So we invite you to visit the website, review the information that is there, and join us in this amazing event. So switching back to the presentation today, I would like to introduce our speakers. Guillermo Meyer, consultant and technology focused on digital transformation strategies, taking advantage of new technologies and methodologies, and providing leadership to drive innovation in clients and their businesses, with more than 25 years of IT experience in multiple industries. And Eugenio Ferrigno, mechanical engineer, Navy veteran, and MBA, with more than 25 years of experience in the energy industry, innovation leader and digital transformation, member of the SPE, Society of Petroleum Engineers, with various technical publications in international events. I would like to highlight that Guillermo Meyer is VP of Business Development at Globant, while Eugenio Ferrinio is Business Hacking Director at Globant. Today, our sponsors are Pan American Energy, Keenan Spalding, Globant, Third Turn, ProJail, Monio Azul, and Prapia. So I invite you to enjoy this amazing presentation. Thank you, Guillermo and Eugenio, for sharing your knowledge, experience, and insight with all of us. The stage is yours.
Thank you very much, Ariel. And it is a pleasure to be here. Thank you very much for everybody to participate. Please, Guillermo, take the control of the presentation. Okay.
Here it is.
Beautiful. Okay, welcome everybody. Today we are gonna talk about blockchain and smart contract, very focused in the energy and oil and gas industry. We are gonna try to do this journey in a very soft way in order to try to teach everybody, even the people that it is not expert in the technology, in order to give an idea and join the different activities that we can do to take advantage of this technology. Next. This is the roadmap for today, and actually, okay, it is okay, the next one. And actually, I invite you as a breaking ice quiz to go to this pool. It is in LinkedIn. Actually, you can scan by your phone. I'm gonna put here in the chat. I don't know if everybody see the link. You can do this or later. It is not mandatory to do this, but we post today this poll in LinkedIn in order to try to check what is our paradigms, or what we believe about blockchains and how it's gonna impact the most in this industry in the following 5 years. And we set these 4 options. One is impacting the OPEX in what we call Uberization services. This is try to use blockchain and a smart contract to do smart services and reduce cost. That could be an option. Another is in the managing investment, CapEx, and the way that we use our capital. And other people, or maybe you will agree that maybe the most impact that we are going to see it is in the green energy tokenization. In this way, in this challenge in the energy transition and going green, maybe blockchain is going to be the tool that it is going to be the game-changing tool for doing this. And finally, the carbon mitigation that maybe looks like the one before, but it is another game. Carbon mitigation has to do more with how we move to hydrogen, or how we record and improve efficiency, energy efficiency in the market. It is up to you. Just for your knowledge so far, and we are gonna see this is such a game. Most of the people we released this poll a couple of hours ago, but most of the people so far, we are gonna see if we can change this after this presentation. Most of the people agrees that more than the 30% that the option is the number one. The people believes or foresee that the OPEX is the way. We are gonna see. I hope we can change your mind or open your mind along this presentation. Next one. And finally, to give you a context, what we set this slide here because we are gonna share this presentation, and this is for someone that maybe it is not gonna see this presentation live, and this give like a general introduction, but the idea is that what we see is among the 4.0 technologies in the new digital revolution, blockchain it is without question one of the key technologies, but there are a lot of misunderstanding or different point of view around blockchain. Many people, most of the people believes that blockchain only has to do with um, cryptocurrencies, and they say, okay, maybe we can use blockchain for move from real money to cryptocurrencies, or maybe a blockchain, the only sense that it has to do it is for saving or avoiding taxes. No, I don't know. There are a lot of misunderstanding around this, and very few people understand what is going to be the impact, or what is already the impact or the next step, especially in the oil and gas and energy market. What it is for real, something true, is the numbers and the impact that nowadays blockchain is having. It is very big, and some numbers I leave you these for we are not going to discuss now, but this is for your reference. uh, Everybody agrees, the technology expert and the people that are analyzing trends, that blockchain, it is going to be one of the game changing technologies, that it's going to impact big numbers in the industry in general and in the global commerce. And then I hope along this presentation, we are going to understand why and how. Guillermo, is all yours.
Okay, thank you, Eugenio. Hi, everybody. I'm Guillermo, and the idea, as Eugenio said, we're going to go through some blockchain concepts. So it's our belief that if you understand what's really what's behind the shell of the things, and you understand the nature of everything, it's simpler to connect and identify the usages of the technology. So some of you may already know blockchain, so sorry for that for those, but for people who don't know what's really blockchain is, I hope this very introductory explanation I will do in the next slides may be helpful for you. So Eugenio mentions about, typically people think blockchain is a cryptocurrency, but actually blockchain is a technology behind Bitcoin and other cryptocurrencies, right? So at the end of the day, blockchain is a distributed network of nodes, right, of peers. Actually, a node is a computer, right, a server, a computer that requires no central authority. So there's no, the blockchain is no in a place, but it's everywhere. It's distributed in this network of peers, where each node contains a replicated set of transactions in a, let's say, like a distributed database, right? So there's data records distributed in each one of these nodes that are replicated in all of the nodes, right? So it also provides you can verify the transaction into that records that are verifiable, right? So there's no, they are tamper-proof, so you cannot change the data of that. So it's like an append-only record database that you are adding and adding over and over again. And there's also a consensus mechanism to ensure that what is stored in each one of the nodes is agreed by everyone. So imagine that there's a lot of notaries, right, having a notary book, and each one of the notaries is writing records in that notary books that are only append only, they cannot be changed, and there's a verification of trust. So that's actually what it is. So going to today, we have the Internet of Information, that when we see the internet start with it's oversimplified, right? But it's a TCP/IP protocol, right? From TCP/IP protocol, the first application were the World Wide Web and the email, and then it's evolved to other use cases like social network, cloud, e-commerce, and others. So think now we are in the Internet of Value, where blockchain is actually the basic operating system or protocol for this distributed computing and storage of information. The first application of blockchain was a Bitcoin, right? And there's other applications after that. So we have other cryptocurrency, but also a lot of other use cases that we will see later, right? So why was it invented? Because there's a history behind the author or the creator, Satoshi Nakamoto. I will not talk about that history, but the idea was the only way to interact and transact between people in the financial system was with a central authority, right? So you need somebody to provide trust. If somebody needs to send money to another body, they don't trust each other. So there's untrust between the parties. So there's a central authority that provides the trust. So I can send money from me to my peer, my colleague here, but going through this central authority. What a blockchain brings on the table is the disappearing of this central authority, right? So the trust is provided by cryptography, right? So cryptography provides the trust because the untrust will continue between the parties, right? So this is why it was invented, to remove the central authorities and to allow a set or an ecosystem of parties that don't trust each other to transact between them with no need of a central authority, right? So some of the key characteristics of the blockchain is it's decentralized, right? So we have peers that no central authority. There's no single server in spite of, okay, we can do a failover or whatever, but there's no single place where the information is. It's distributed in each one of the node, right? So each one is independently. So it provides a lot of resiliency. So then we have the proof of ownership. You can prove who own each transaction and who was the author of each transaction through digital signatures and cryptography. So you can prove who create each thing. There's tamper proof, so no one can change the data that has been stored in the blockchain. And there's also a consensus network. It's like let's say like a voting. It's not a voting, but it's like everybody agrees that this is a truth, and if the majority agrees that it's the truth, it's the truth, right? So it's important. We will talk about the consensus model. So that are the key characteristics, right? So decentralized, resiliency, it's a database, append only, tamper-proof, and cryptography to ensure security and proof of ownership. We talk about the transactions and the blocks. So the name blockchain, it's very simple. It's a change of blocks, right? So it's silly, my explanation, but actually it is what it is, because and what is a block? A block it contains transactions. So imagine the transaction like lines in a double entry bookkeeping ledger, right? So you put things that gets in, things that get out. So you record. I also mentioned this example like the notary book. So let's suppose a notary clerk writes in a notary book lines of information. This may be a Bitcoin thing, or maybe, I don't know, a carbon footprint offset, or a credit or something, right? Or a traceability of something. So anything you want to store, you start putting this here. And the blocks are a grouping of this transaction at a certain number, right? That are that collects all this data together like a page, right? So going to the analogy, the transactions are the lines on the book, and the blocks are the pages of the book. So each page is connected or linked to the next page. I will explain later very easily how it is. And you cannot remove a page from the link. You cannot remove a block. You cannot change the block or change the transaction, right? So this is a very good analogy, a notary book where each block is a page and each transaction is a line in the book. So we talk about also about consensus mechanisms and what it is. Okay, a consensus is when is something that allows all the participants of the network to agree on the version of the truth, right? So what really is, and it's very crucial in a decentralized and distributed computing network, right? So as there's no central authority that can say what's true and what is not true, the mechanisms to do that is very important. So there are special nodes. The nodes are peers, but there are different roles. Some nodes are miners or validators, right? So the node that specific has the task to validate and agree on the quality or the truthfulness of that transaction into the block. And there are two key mechanisms. There are more of that, but the key ones and the most popular are the proof of work and the proof of stake. The proof of you may have heard about the impact of the Bitcoin on the energy and the consumption of energy, right? So this is because the Bitcoin today use proof of work as a consensus mechanism. So what it needs, the proof of works, it has a puzzle or is a race for the miners to resolve a very high complex mathematical math system, math problem, sorry, and it's a race where the first one to solve that puzzle or that math problem wins the race. Each 10 minutes, right? So every 10 minutes, there's, I will see in the next slide, in an example, each 10 minutes, there's this race and all the validators and managers are trying to resolve that problem. The one that wins the problem resolution gets awarded to validate the block and add it to the blockchain and win a prize, typically a reward in the case of Bitcoin, in the case of Ethereum, right? Or in the value that the network provides. The proof of stake actually is we have validators that has a deposit of warranty into the network, and that provides more chances to get selected, typically by randomly on being selected to validate the block. In this case, the proof of stake use a lot less computing, right? Because it's just putting an investment on the network to say I want to validate that block, and if I put more money, I have the chance to do that. If I make a tamper or I make a hack to the network, I lose my stake. So there's a trade-off between that. So the proof of work, who has more computing power has more chances to win, and the proof of stake who puts more money has more chances to be selected. So that's why when we talk about the impact of the blockchain in the consumption of energy, because the miners needs a lot of computing power to be faster than the others and win the block adding to the chain, right? So I will explain it very simply here. So let's suppose we have this, and this is very important to understand when we talk about the impact of the blockchain into the energy, right? So imagine we have this network of peers, and we have a special nodes. In this case, we have, in this case, 3 miners, right? And we have a blockchain here with, this is the last part, with 2 blocks. Each one of the chains of the blocks are sealed with a key, right? This key is something that locks the transactions here. I will not explain in detail, but at the end of the day, it's cryptography. They use a hash to do that, right? And the next block contains the key of the previous one. So what happens is the nodes start adding transactions to the network, right? So I have transactions from 1 to 5, and these transactions are here, but they are not yet in the blockchain. They are not yet in the database, right? So they are not here. So, and the here is in each one of the nodes. What's happening is each one of the three miners create a candidate block, getting the transactions into the block and using the key of the last block as part of it, right? So what they do is they start looking for the resolution that actually is using a hash algorithm. I will not explain because of time in detail, but actually they try to, the only way to resolve this problem is by brute force. They repeat and repeat and repeat and repeat, trying different combination of numbers, of keys, until they get one expected result. And the first one who find the expected results win the prize, win the right to add the block. So in this example, this miner found a key for this block, and what he can do is he can add this to the blockchain, right? So, and the other blocks are discarded. The transactions that were not part of the block are still for the next round. This happens every 10 minutes, for example, in Bitcoin, right? So every 10 minutes, there's around 1,000 of transactions in blocks that are trying to be validated, and the one who win that puzzle adds the transaction in the block. Again, this is just illustrative. This block here down is replicated in each one of the nodes as a database that is adding records and records and records, right? So the other point after understanding this is the smart contracts. As the title of the presentation talks about smart contracts, let's understand what it is. Before start to talking about smart contract, we can talk about the different generations of the blockchains, right? So in 2009, the first generation of blockchain, where the first application was the Bitcoin, has some features, right? All what we just described, right? So the secure, tamper-proof, no intermediary, resiliency, right? So the application was a digital currency, that was the Bitcoin, but the throughput, look at here, it's 7 transactions per second. So what it means, I talk about every 10 minutes, a blockchain, a Bitcoin in this case, that is based on blockchain, as I said, gets 1,000 of transaction, right? And each one of these transactions are added to the block. So at least you have that number. So at the end of the day, the throughput is very, very low. So that's why Bitcoin today is most used for storing value and not for transacting. So after that, there was a second generation that said, okay, I think we need to do programmable money, or we need to add programs into the blockchain. So that's where Ethereum came into the picture, right? Ethereum, as a second generation of the blockchain, introduces the concept of smart contracts, and also distributed applications and digital DAOs, distributed autonomous organization, right? So the throughput was increased a little, and most of it because they are using proof of work that takes a lot of effort and computing power, right? So, but other applications start to appear, like distributing apps, like gaming, decentralized finance, identity management, and others, because now it was possible to start programming. I will explain an example of this in a minute. And today there's a third generation that are we are using proof of anything, typically proof of stake as one of them. We have here the other cryptocurrencies or the others solutions like the Solana, Polygon, Cardano, Binance, right? So it increased a lot the scalability, the interoperability, the throughput. It was in hundreds of thousands of transactions per second, right? So there are a lot of new solutions, innovation, future. Mostly of the things the industry is doing today is on here, on the third generation. That has been a journey from the Ethereum and the Bitcoin in the previous generations. Another point is, I didn't mention before, but the blockchains can be private or public, or also maybe said permissioned or permissionless, right? So it applies to Ethereum, for example. So we can create an internal network of nodes that can be owned by a set of ecosystem of oil and gas companies, right? So where they deploy a blockchain with permissioned, though nobody can enter in to be part of that node. A permissionless is, for example, the Binance, where you can add a wallet and start operating, right? So it's free to add, right? So in the permissioned is mostly used for enterprise solutions that we're using this technology in use cases for the industry. So the smart contracts again are programs that are stored in the blockchain. So you can code. Typically, Solidity is one of the programming languages that is used here, and the programs are stored in the blockchain, so they inherit all the features of the blockchain. They are immutable, they are resilient, they are distributed, right? So that's what. So you write there a contract or a program that does something at a given when some condition is met, and nobody can change that, right? So when you deploy the contract, the smart contract in the blockchain, all the parties that participates in the blockchain agrees on that contract, on what will happen with something, what a condition is met. So that's why it's called the smart contract, because at the end of it, when you subscribe to the blockchain, you adhere to the rules that are programmed into the smart contracts. So as I said, a smart contract came from the Ethereum. They have the Ethereum virtual machine. It can be ported to other blockchain implementations. So the blockchain there are many implementations. One Ethereum is one, but there are others, Cardano, Solana, Rootstock in this case here, that is an Argentina company. So I think with an example can be very clear here. So let's suppose we have here a smart contracts blockchain, right? We have an ecosystem here of trucks that are bringing material. We have a company receiving the material. So in this case, there's an agreement between the company receiving the material and the transportation delivering that they will pay a fee to the provider based on the delivery time and SLA's compliance, right? So there is a smart contract that they both agree that is stored in the blockchain, so nobody can change it. It's the contract that this will trigger the smart contract when the status is delivered. And what happened will calculate the delivery time, calculate the fee based on the delivery time, and pay the fee, right? So this is given a condition, something will happen. So in this case, the truck is here, the ship, this is a transaction that added to the blockchain, right? So the ship is at this time, then the ship moves, and there's a sensor that is in IoT. So we are start connecting things here and add a transaction to the blockchain, right? Saying that it's moved here, then the truck move again, that we have another time here, and then the truck gets into the parking size of the company, and there's a camera that detects the truck and set deliver it, right? And trigger, and when it's delivered, it will trigger the smart contract. At this time, it will calculate the fee, and pay the fee will add another record into the blockchain saying the payment has been done, right? So as you see, you can automate processes. If you go for the ones that knows about database, it's like a trigger of a database. I'm sorry about the pre-release of the blockchain, but it's maybe a similar concept. You have a table where you insert a record, and there's a trigger that is execute on any event of the record and do something, right? So we can think on that. So what companies are doing is using this platform to create solution where the logic of the solution of the process is into the smart contracts, it's deployed into the blockchain, it's distributed between the nodes, each participant that are untrusted between each other, a competitive landscape, they adhere to that rules that are written in the smart contracts, and they start doing operations, right? So, and that coordinates. An evolution of this is what is called distributed autonomous organization that actually provides the rules of a company, right? An autonomous company running on these contracts. So just to have, I will not go into detail, but I want to show, because somebody may say, okay, Bitcoin, blockchain, Ethereum, period, right? So there's a lot of things going on here. So and this is just the tip of the iceberg, right? So if you look at Ethereum, decentralized finance ecosystem, you have payments, infrastructure, know your customer, identity, stablecoin, insurance. I mean, there's a lot of things going on. Each one of these is a company using the blockchain technology in the different platforms, right? So we have here the Polygon ecosystem that is compatible with Ethereum. We have here a non-fungible token. That is another thing that is also, I will not explain now, but if you're interested on an NFT, you can take a look in internet. But is a token is converting the physical object into digital objects, right, to create scarcity and create value from that. Gaming, we have decentralized finance, bros, wallets, right? So banking, a lot of industries. Again, here is another high-level view of other industry in energy, creating solutions for, like in this case, Essentia. We have land registry, we have shipping, real estate, we have fishing here, for example, to use to record where a fish has been caught, right? So it's there. Music, enterprise, carbon offsets. I mean, a lot. I mean, all the industries. So imagine if you need, you have a problem where you have an ecosystem of parties that don't trust each other, and you want to define a process with a set of rules, and you have information that triggers that rule and is shared between each one of the parties. So blockchain is a technology that can be used for that. So you can use blockchains to connect these parties, replicate information, store the data, and create the rules with a smart contract to trigger and make it happen, right? So so I will hand over here to Eugenio, right? Yes, go ahead.
Thank you very much, Guillermo. Outstanding. By the way, another Guillermo, not you, some other Guillermo, Guillermo Piciano, asked us if we are going to share the presentation. I type, thank you for the question, because maybe some other people missed that part, but yes, we will share this presentation, and actually we will share with all the links. For instance, in this case, I want to present 3 examples that I took for the Journal Petroleum Technology magazine. I picked that source just because we are talking about energy, and it is a magazine or a source of information that everybody trusts. In this particular case, the idea is trying to tell you what is happening around the oil and gas market. And for instance, the case that you see in the middle is something that came from the shale oil development. You know, everything around shale oil brings a lot of innovation. It challenges our industry. It forces us to think in a different way, and by doing that, adopting a new technology. And of course, blockchain was part of that. And what in shale oil, something that happened, I guess everybody is involved or not, we have a very huge challenge around logistic. We have a lot of trucks for delivering water, chemicals, sand, a lot of material. And in some cases, or in some areas where we have a lot of small and large companies, they compete each other for these resources and services. And what they do was they implement a blockchain that allows that they pay for every track as a performance, and then they can compete. Every company, or even every driver. No, it doesn't, because in this kind of technology, everybody play. And if one driver perform with better KPIs, they receive more money and they are better paid. And the second article I'm gonna give you, it is the first one, the one is to the left. Actually, it was a new version of the previous one, because since in 2019, they got a lot of good results around this experience. They improved this and they include more services, more product, always gaining efficiency and everything from competition. And you can see here all this information. Another big things that came from blockchain was the matter of secret of the information. Why? Because when you have an open network like this, and if you have a company, and maybe you don't want that your competitors knows how much are your payoff, or or how do you perform. Maybe you want to keep that secret, and that is something that also blockchain brings. It brings competition, it brings an open system, but also it keeps your confidentiality in the information that you need to keep confidential. And the last one to the right, it is another article that it is more focused for CapEx, actually also for shale oil, where you need to drill new wells, and you need a lot of services around the drilling. And there is tools, and it talks about tools about how to receive investment, how to capitalize all the costs, and also how to build a smart contract around the drilling services. And actually, that is something that it is not a blockchain yet, but we are working in Latin America with a couple of companies in this direction too. No, but that are examples. And please, the next one. And something that is even new, and a lot of people are talking more and more. And actually, if you're looking for information about how is blockchain impacting the market today, especially because of Shell is pushing in many initiatives how to use blockchain for trying to get benefits, in some cases to reduce paperwork for when you need to trace material or components, in a global market. Sometimes for any piece you need a lot of paperwork, and that is cost and time. And by doing with blockchain, we can improve and reduce that. And also in the energy transition, where we need to accelerate the low carbon migration, there are several initiatives. One has to do in order to trace, again, traceability. Once again, one of the big skills of blockchain, traceability of the hydrogen, because I am not talk a lot about this, but you have gray hydrogen, blue hydrogen, green hydrogen, and at the end of the day, every mole is the same, but you need to know where it came from. Blockchain can help in that game. And also when you have a very big grid and you have a lot of companies or even people, individual people that generate energy, you need to know as a consumer where the energy came. It could came from a solar panel from your neighbor, or it could came from a atomic or nuclear central from, I don't know, another country. You need to know where that electron came from and how green it is. That is another area where blockchain it is making a lot of sense. And finally, also validating the carbon credit program and all the efforts to reduce carbon capture and reducing. And next one, please. This is just an example that I took from the previous article. If you see the fight for the starlines, these very, very small birds that live in North America and Europe, you know, everybody or every bird, it is just one individual component, but all together, they are not just flying together. They don't have one leader. They don't have no organisms, no one that say, hey, go to this direction or to this another. They are all free, but somehow they make all together create something that it is bigger than each one, that protect themselves, give and give, you know, extra advantage for them against the another animals that want to attack, or for any other reason, or for calling the colony or wherever. The thing is, if you think about technology, the only technology that give us the power to call all the different parties when we need to do something bigger than us, in this case, the energy transition and the net zero carbon goal, the only way, there is no one government, no one company, no one, just one organisms that it is going to lead this. The only thing it is that we need to do this all together with own decisions, but with some tools that allow us to do this change as these pairs. And the only technology in place for doing that is blockchain. That's why blockchain, it is a game-changing technology, and it is my personal point of view. I am, you know, I am not Nostradamus or anything like that, but what we are going to see the most blockchain it is regarding the carbon zero transition. Okay, final thought. As you know, and as we discussed, blockchain it is part of cryptocurrency, but that was just one part. It is more than that. It is a cutting-edge technology. It is not something in the future. It is nowadays present among us. Even in our industry, we want to see more present, but it is going to happen. It depends of all of us that's happened, because, and this is to me the key message here, as Guillermo explained before, for building a smart contract and all this, or taking advantage of the blockchain, before, or in order to do that, we must have digital transactions in some digital way. We need to get out of the paperwork or all the manual process. There are a lot of opportunities in our industry in that direction, and that is something that we need to start to doing now, because if we don't do that, all the other benefit that we see in terms of operational efficiencies or capital access will not happen until we move all our operation, all our process to the digital world. And the more automated it is, the better it is to deploy a blockchain layer on top of that to take the advantage of everything that we talk. And you know, the rest of the thing is what we discuss. And for sure, in energy transition, the key technology that it is going to help us to manage that and accelerate this is going to be blockchain. And then I think that is all. And we are very open to question. Guillermo, I think I have one from Diego.
Eugenio, Guillermo, thank you very much for the presentation. It has been very clear and very well explained what this technology is about and how we can apply that one to the energy industry. I think that example helped a lot. So now let's go with the question and answers, and we can go to the question and answer session there in Zoom, and we can cover every single question that we have there. So the first one is from Guillermo Pisano. I understand for a smart contract, we need to use Ethereum platform. Any idea of associated costs?
Okay, yeah, Ethereum was the first platform in the second generation of blockchain that introduced the concept of a smart contract, but it's not the only one, right? So it's like saying, I don't know, going into technology like the Oracle database or the SQL Server database or the MySQL database, right? So there are a lot of implementation of that. So you don't need specifically being Ethereum. You can use another one like, I don't know, Cardano or Algorand, right? So there are other platforms as well. Each one may have their specific economic model. Some of them are permissionless, where you need fuel, right? So invest in the cryptocurrency that fuels the contracts internally, or you can build your private network, right? So your private blockchain, and you can deploy an open source platform where you don't have a cost more than the price of supporting or running the nodes, right? So it's not free, but you don't need to pay a license in that case. So there's a lot of options. So I hope that answer your question.
Okay, the next one is from Marco Lilini Real. Which are the ways that the company have to apply a smart contract? So
Okay.
I would like to expand on that one, and I think that the question also can be, what is the roadmap from the scratch, in the sense of any company that, go ahead, Guillermo. Sorry.
No, yeah, the maybe answering this, and the next one I see here is what are the roles of the lawyers and attorneys in this kind of technology? Okay, first of all, the word, do not get confused on the word contract, right? So in this case, the smart contract is the technology that allows us to insert a program into the blockchain, right? So I will explain the lawyers and attorneys in a minute. So the company can apply the smart contract by understanding a challenge or a problem they want to solve using this technology, or where this technology supports or has the features like distributed technology. You have the data that is added and append only. You have an ecosystem of stakeholders that don't trust each other. There's no central authority. So if you have a problem that can be framed into a blockchain solution, that's the first stage. Once you identify that, you understand the type of platform for blockchain that you can choose. There's a lot, right? So you need to choose if you're going to be a public one, a private one, what type of platform, right? So that's the second, defining the architecture. And the third one is start modeling the solution. So you start modeling the processes, the interaction between the parties, the type of transaction that Eugenio mentions about digitizing the current processes to be able to be onboarded into the blockchain, right? So as part of nodes of the blockchain. And the last part is adding the logic of the process, right? And the logic of the process is built into the smart contract and deploy, right? So that's how I would do the roadmap of adopting the smart contract. So understanding the problem, create and map it to a blockchain, creating the architecture and the platform that will support that, identifying the parties and allowing them to participate in that platform, and then building the programs and the logic into the smart contracts to make it happen, right? And the other one regarding to the lawyers and attorneys, let's suppose, I mean, lawyers and attorneys will keep doing what they do today, right? So let's suppose, I don't know, Ariel, I don't trust you and you don't trust me, right? So we have a contract and we have a lawyer that or a notary that we sign a paper, right? In the real life, right? Now we want to automatize that contract somehow, and we will use the blockchain to do that. So the smart contract eventually will translate what is written in paper and signed by contract by lawyers or verified by lawyers. The smart contract will take the logic into the paper and move into the technology to automate and make it happen, right? So, and as part of the blockchain, that is immutable, nobody can change. It's proof of ownership. It's with cryptography, digital signatures, and also it's can be read and open. You can see the smart contract. So that has the features of digitizing this paper into the smart contract. But at the end of the day, the smart contract does not imply specifically some lawyer or attorney as part of it, right? So I hope it was somehow clear.
Thank you, Guillermo. There was another question from Diego Mondrick. How is that the validator miner are certain that they will receive enough problem to have a profitable business? I think that is related to Bitcoin and
Yeah, I answered that in typing, but yes, the profitable business. Yeah, what I put here is depends, right? So if you want to be a miner of the Bitcoin, you will need an investment on infrastructure or servers to start mining and be able to win the chance to mine a block. And the reward is that each block that is mining in Bitcoin, you mint a part, a fraction of a Bitcoin, right? Some Satoshis, that is the fraction, right? And that is get into the miner as part of the reward, and also all the fees, that each transaction has a fee. So as the Bitcoin price decreases, maybe that's not a good business for the miners, right? But so typically that's the role of the miners into the ecosystem. The other point is typically these platforms allows to reduce or increase the complexity of the mathematical problems. So if the network can self-regulate and reduce the problem, so that it will need less power of compute to have chance to resolve the mathematical problem, right? So, and that is something that the network can do. So because to make it profitable, instead of investing a lot of money to have a supercomputer to solve the problem, I may have a cheaper computing to solve a simpler problem, right? And still keep my profit and my business, right? So I mean, it's a very complex scenario where there are a lot of variables, right? But yeah, that's my first answer on this.
thank you, Guillermo. Finally, I would like to share that we are going to share the presentation with everybody. The session has been recorded, so it's going to be available in our channel in YouTube. So anybody that wants to come back to the presentation can go there and see any specific that they want to see. Well, finally, I want to say again, thanks to Guillermo and Eugenio. It was an amazing presentation. I think that it triggered a lot of additional questions in order to how to implement this amazing technology in our industry. And obviously, after the presentation, all of you are going to be connecting in order to continue discussing about blockchain with the audience, just in case that anybody has any inquiry or additional questions. So having said that, thank you everybody for attending, for your question, for your attention. And obviously, we are fully open to continue creating relationship with all of you. Thanks, Guillermo. Thanks, Eugenio. And Thank you, Alejandro, also that is on
Thank
the
you.
background
Okay.
there. And he was a key person here in order to organize this webinar and allow all this audience to enjoy Guillermo and Eugenio. Well,
Okay.
see you. Have a wonderful day.
Yeah.
Thank you.
Thank you very much. Follow us in LinkedIn, and any question that you have today, tomorrow, we are very welcome to respond. Thank you.
Bye-bye.
Thank you.